Okay, let's dive right into vectors. So, what is a vector? Well, um, for our purposes, we're not going to be super technical about it, but a vector is a list of numbers. So, I might have 2.2, 1.5, -3, -2, something like this. They're usually written like this in a sort of vertical column with square brackets around it. That's how our book is going to do it. Sometimes if it needs to write it in text, it will write it, like this with parentheses. But yeah, they're lists of numbers. Order matters, and we generally, if this is my vector, x, then I would say that this vector has 4 elements, so it's a 4-dimensional vector. It's a vector of length 4, because these are, we're in math terms, these are real numbers, the 2.2 and the 1.5. We will often write that this vector x is an element of R4, like that. So x is this means x is in R4, 4-dimensional vector, right? And we can sort of reference this individual elements of the vector using subscripts. So for example, x sub 3 is -3. And this, one thing just to be aware of here is that the textbook is going to use 1-based numbering. So x sub 1 is 2.2. It's quite common in programming languages and programming contexts to use sort of array style indexing, which would be, that x sub 0 is 2.2. And so, for example, we're going to talk a little bit about implementing some of this stuff in Python in using the NumPy library, and that's the sort of notation they use. Of course, because it's a Python style, they would write it like this. They would say x sub 0 is 2.2. Either way is fine. Just don't get them confused as you're doing your work. And the textbook is always going to use 1-based numbering. So this x vector that we were just looking at has 1, 2, 3, 4. And in general, once a vector is made, it does not grow or shrink or change elements. They're in some sense immutable things, right? That x is it's this vector that has these 4 things. The vector that has these 4 numbers in it, we're calling x. Of course, I wrote 4, but you could imagine having any number, 10, 100, even 1. Although a vector with only 1 element in it is really just a real number. But there's no reason you can't. Any other things about that? Okay, so a couple of other things just to sort of be aware. In terms of describing the vectors themselves, I used x for this. Some treatments will try and use some notation, like making it bold or putting something like a little arrow on top, and I will do that sometimes to make it clear that it's a vector, but I will not in general, and the book will not in general. You just have to pay attention and say, oh, this x thing is a vector and this other one is not. It's a real number or whatever. So just be mindful of that. And then a couple of other things just to sort of be aware of. One thing is that in the same way we do subscripts here, we could do like a slice. So I might say, let me back up so we can actually see the thing here. I might say x sub 3:4, meaning the slice that has those. Maybe it's better if I pick a different number. Let's say 2:4. How do I do this? Oops. Okay. Which would be like a subvector, right? And that's 1.5, -3, -2, right? And then you can also stack vectors. So, if I had some vector A that's 1, 2, 3, and I had some vector B that's 0, 5, 6, then maybe I make some vector C that is A and B stacked together. And again, this is just a notational thing. But that vector is going to have 6 elements long, and it's going to be 1, 2, 3, 0, 5, 6. This is all just, just making sure we're on the same page for all the notation stuff. A couple other sort of like special vectors that you will often see. One of them is the 0 vector. So the 0 vector is just the vector that's full of zeros. So for example, if I had a 3-dimensional 0 vector, it might look something like 0, 0, 0, like this, right? And in this case, like I did draw a little arrow hat on it because I think it's like more easy to understand that like this is the 0 vector. Sometimes the book will also put a subscript on here to say like this is the 3, 0 vector, meaning the one that has 3 as opposed to the 10, 0 vector or something like that, right? You could similarly have a 1s vector that works exactly the same. 1, 1, 1, right? It's just the vectors that have the, each element is 1. And if you wanted to be sort of more formal about it, you could say something like, for all I, 0 vector sub I is 0, right? Or 1 vector sub 1. And then one other vector that's the unit. So this is 0 vector, 1 vector. Now we're going to talk about the unit vector. This is our other fancy vector. The unit vector has a 1 in one place and a 0 everywhere else. And in that case, we usually do the subscript in the location where the 1 is. So for example, if I had E1, this is different from this where it was the length over here. I might still put a thing on here, but this is definitely a vector. E1 has a 1 in the first place and a 0 everywhere else. E2 has a 0, 1, 0 pattern, right? And so on. And again, this could happen for any length of vector. Okay, so examples. The book has a big section of examples, many of which it returns to over the course of the book. So it's good to just kind of thumb through those. I'm just going to mention a couple that I like just to kind of keep in my head. I mentioned a few of these already, I think, but one thing that you could easily imagine is to have a color, and so maybe you have red, green, and blue values, right, in a 3 vector, right? So maybe you have, and I don't know the numbers well enough, but if it's 128, 128, 128, maybe that means it's gray, right? But obviously, if you change those numbers around, you get a different color, and each position matters. You can, and then you could imagine a huge vector that has all 3 of these for every pixel in an image, say. So imagine I have a full image, and for each pixel, I have all 3 of those numbers, right? So if this is 1,000 by 1,000 image, I can just stack them, just like we were talking about stacking the. So it goes like red, green, blue, right? Dot dot dot. Make a really long vector whose length would be 1,000 times 1,000 times 3, right? which is whatever, 3 million elements. Whoops, I said equals 3 times 3. So 3 times 10 to the 6th elements in this vector, right? And then all sorts of image processing things that you might want to do with that. Another example is word count in a document. So, you know, I have some big body of text, an article or a website or a book or something. And then I just have a dictionary, you know, so as I've got, you know, a ant at whatever, ... zebra, right? And then for each document, I just keep track how many times did that word appear in the document, right? And that's you know, often something like that is often the first step to some kind of language processing application. One other thing just is like a time series, you know. So let's say I'm tracking the temperature over time at my house, right? So during the day it gets hotter, and then it gets colder, and it gets hotter, and it gets colder. Maybe there's a cold spell, whatever, something like this, right? And I've got whatever, however many 365. Let's say I've captured a year's worth of data. Then I have a 365 vector that just has the temperature at each point, you know, 90.1, 15.1, whatever, that kind of thing. And it would be an element of R365. So those are just some ideas to, and like I said, the book has a bunch. I'd definitely say check them out. Yeah, keep those in mind as we go forward. It's helpful to sort of like have some examples of what a vector could look like. And next topic is adding and scaling vectors.